Alright guys, in this video, this is the 2018 AMC 10 Test A, question 7, alright, and I'll be showing you how to solve it, alright. So, it's telling us, for how many, not necessarily positive, integer values of n is the value of 4,000 times 2 over 5 to the n power an integer, alright. So for how many, not necessarily positive, alright, remember that, integer values of n. Alright, so n is right here. Is a value of 4,000 times 2 over 5 to the n power an integer, right? So we want to find all the values in which n can be, n is a number, n is an integer, and we want an integer result if we plug in a number for n, alright? So how many integer results are there in this function right here, okay? Well, to see that, we have to see how many times we can multiply 2 over 5 so that it will result in, so that 5, when we divide 4,000 by this power of 5, it will be a positive integer. If you don't really know what I mean, here's what we're going to do. We're going to prime factorize 4,000, alright? So 4,000 is equal to 2 times 2 times 2 times 5 times 2 times 2 times 5 times 5. I believe so, right? Because 10 times 10 is 100, times 10 again is 1,000, times 4, yeah, that's 4,000, okay? 1, 2, 3, 4, 5. Alright, so there we go. We just prime factorized it, alright? Now, for example, if we multiply, so when we raise 2 over 5 to the n power, when we raise it to the power, it doesn't matter what number we multiply this 2 by. It doesn't matter how big this number 2 is, because it will still be 4,000 times 2, whatever value of 2 times to the n power. Because remember, 2 over 5 to the n power is 2 to the n power over 5 to the n power. Alright, remember that, okay? And so all it really matters is what number the bottom number is, alright? Well, we have to see if 4,000 times 2 divided by whatever number this is divisible, alright? So you know that the number, let's start off with the number 0, alright? If we plug in 0, well, that's just 4,000 times 1, and that is also equal to, that's an integer, alright? So that we have one value. If we plug in 1 into this, right, where all we have to divide is by 5, alright? It doesn't matter about this 2 right here, okay? So we divide this 5, and we know that's an integer as well, right? That's 800. So let's plug in the number 2 here, alright? 2 over 5 to the second power, alright? Well, what is that? That is 4 over 25. And we see here in the number 4,000, 25 is a factor of 4,000, alright? Because we have 5 times 5 right here. So we know that if we plug in the number 2, on. If we plug in the number 2, that will work out. Alright, what if we plugged in the number 3? Alright, if we plugged in 3, that would be 8 over 125. In other words, 2 to the third power over 5 to the third power. And remember, all the bottom number is all that matters right here, because that's what we're going to divide 4,000 by. And so, is 125 a factor of 4,000? Well, it is, right? Because we have 1 5 right here, times another 5 right here, times another 5 right here, alright? So we know 3 is a factor, alright? Or 3 is one of the values of n that can work. So let's plug in the number 4. Well, if we plug in the number 4, we'd get 5 to the 4th power, or 2 to the 4th power over 5 to the 4th power. And we know that 5 to the 4th power is not a factor of 4,000 because we only have 3 5s here. So we know that we cannot go greater than 3, alright? 3 is our max. So let's try going down to the negative values, okay? So if we go down to the negative values, we can plug in negative 1 for n. And all that will be is just the reciprocal of this, alright? So 5 over 2. So we're going down to the negative number now, alright? So if we plug in negative 1, that would be 5 over 2, and we know that would work. 5 over 2, or negative 1 is going to produce a positive integer. All right. If we plugged in -2, well, if we plugged in -2 for n, that we take the reciprocal of this, so that'd be 5 squared over 4 or over 2 squared. All right. And remember, the bottom number is really the only number that counts because that's what we're going to divide 4,000 by. And so that we see 4, because 2 squared is 4. 4 indeed is a factor of 4,000 because we have 1 2 right here. We have another 2 right there. All right, so -2 is one of our factors as well. We can go to -3. All right, if we go -3, take the reciprocal. It would be 5 to the third power over 2 to the third power. And 2 to the third power is 8. And 8 is a factor of 4,000 because we have 1 2 right here times another 2 times another 2. All right. We're flying through this. And plug in -4. Well, if you plug in -4, we take the reciprocal of this. Then we get 5 to the fourth power. 5 to the fourth power over 2 to the fourth power. And is 2 to the fourth power a factor of 4,000? Well, it is, because we have 4 2's. We have 1 right here, 2 right here, 3 right here, and another 1 right there. All right. Plug in -4. And we see if we plugged in, and we only have, you can see a pattern, right? When we go to the negative, we're counting how many 2's we have here, all right? So in all, we have 5 2's altogether. So our last one is going to be -5. And the last one can't be -6 because there's only 5 2's right here, right? So that would indicate that -5 is our last one. Alright, so let's count up all the values of n we can have. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. And so altogether we have 9 integer values of n, and we have an answer right here. The answer is 9. Alright, there you go. And so all what we basically did was prime factorize the number 4,000, and we counted the number of 5 and 2's they had, and we plugged it into this. We plugged it into n for that. All right, and we included the number 0. All right, and there you go. That's how you solve it.